Alright, here's two more examples of evaluating trig with inverse trig. Here's that flow chart that we introduced in the previous video, and if you don't have a copy of this and you want a copy of it to follow along with, check the video description. There's a link in there. You can click that link and open this up, print it out, and follow along with it if you'd like. So, now problems like this where the function is paired with its own inverse, most of the time these really aren't too complicated, but just to be thorough, we will follow the flow chart and just see what's going on here. So first of all, is there a domain violation? No, there's not, right? So we're looking at example 3 here. Inverse sine of pi over 6. Is there a domain violation? No, there is not, because we can take the sine of anything we want. Okay, we're allowed to take the sine of anything we want. So sine of pi over 6 is totally legitimate, totally fine. Okay, so is there a domain violation? No. Is the function paired with its own inverse? Yes. Yes, it is. Okay, because it's sine paired with the inverse sine. Now, the inverse function is on the outside, but we don't care about that yet. We haven't gotten that far. We don't care about that yet. We don't care which one's on the outside, which is on the inside. All we care about at this point is the function paired with its own inverse? And yes, it is. It's sine paired with inverse sine. So is the function paired with its own inverse? Yes. Is it possible to cancel? Well, let's see. What did that rule say that we talked about in that earlier video? The rule says that the inverse sine of sine of x equals x if what? If negative pi over 2 is less than or equal to x is less than or equal to pi over 2. Okay? Does pi over 6 meet that condition here? Is this true for pi over 6? Yes, because pi over 6 is between negative pi over 2 and positive pi over 2. Okay? So pi over 6 is between these two guys. So as it turns out, yes, it is true. So here, is it possible to cancel? Yes. So then do it, is what we should do. Okay, so inverse sine of pi over 6 equals pi over 6 because BC for short, because negative pi over 2 is less than or equal to pi over 6 is less than or equal to pi over 2. Okay. So in general, inverse sine of x is x if x is between negative pi over 2 and positive pi over 2. And in this specific case, we have pi over 6 instead of x. Well, pi over 6 is between negative pi over 2 and positive pi over 2. Therefore, we can just cancel right away. Okay, so we're good. Good, that's great, that's wonderful, that's relatively simple, not too bad at all. So that's example 3, and the answer again was pi over 6. Okay, how about example 4? Tangent of the inverse tangent of 18.2. So it's trig with inverse trig, so let's go on over to our flowchart. Is there a domain violation? Well, no, we can take the inverse tangent of anything we want. Okay, remember, the domain of the inverse tangent function is all real numbers. So we can take the inverse tangent of whatever real number we want. 18.2, totally fine. So is there a domain violation? No, there's not. Is the function paired with its own inverse? Yes, it's tangent paired with inverse tangent. Notice in example 4, the inverse function is on the inside, whereas in example 3, the inverse function was on the outside. But again, we don't care about that at this point. Okay, we don't care about that right now. All we care about is the function paired with its own inverse? And yes, it is. Tangent is paired with inverse tangent. Okay. So is the function paired with its own inverse? Yes. Oops. Is it possible to cancel? Well, let's check. Is it possible to cancel? What did that rule say for? So we remember the rule for sine and inverse sine, but what did the rule for tangent of inverse tangent say? That one said tangent of inverse tangent of x equals x. For any real x, for any or for all real x. Okay? So for any real value of x, tangent of inverse tangent of x is just x. So actually this is wonderful. So no matter what real number is in here, we're just going to get that real number back. A tangent of the inverse tangent of 18.2 is 18.2 because tangent of inverse tangent of x is x for any real number x. Okay? So specifically with 18.2, we're just going to get that 18.2 back. Okay, so that's example 4, and the answer was 18.2. Okay, so that's two more relatively simple examples of using this flowchart to evaluate some trig with inverse trig problems. Okay, so more examples coming up in the next few videos.